Hello everybody, welcome to another video on Thomas's calculus. Today we are going to work on chapter 4.8. We are looking at antiderivatives. So this table gives us the antiderivatives of the functions. For example, the most important functions you need to remember are x to the power n, the second function sin x, sin kx, cos kx, e to the power kx, and 1 over x. Those are the most important functions you need to remember. So let's look at x to the power n. So x to the power n, the way you get the antiderivative is you add 1 to the power and you divide it by that. So the way you get it is you add 1 to the power, which is n plus 1, and you divide it by that, n plus 1. And you do have to add a c when it's an antiderivative. So that's the first equation. And the second, sin x, sin kx. Sin kx, the way you get the antiderivative is the antiderivative of sin x is minus cos x, cos kx, and you just divide it by the constant k. K could be 2 or half, no matter what it is, you divide it by the constant, and then you get the antiderivative. Of course, you have to add a constant c for the antiderivative. So let's compare x to the power n and look at the derivative and the antiderivative. Derivative, if you remember, d over dx of x to the power n, what you do here is you multiply by when you differentiate the function, you multiply by the power n and subtract 1. So the derivative of this was n x n minus 1. That's your derivative. Now let's take the derivative and then we get the antiderivative of this function. We want to see whether if we get the derivative and the antiderivative, whether we'll get the function x to the power n again. So let's take the antiderivative. So how do you get the antiderivative? You add 1 to the function power x and you divide it by that value. So we add 1, we'll do it using a different color. So we add 1 to the power once and divide it by that to get the antiderivative. Divided by that, we write this and we say we divide it by that. So we will get n times, if you get the antiderivative, n times antiderivative, we get n times x to the power n. That is because these cancel off, we get x to the power n divided by n plus c. So there you go, we get x to the power n back. Now let's take this and get the antiderivative. The antiderivative is the integral. So integral of x to the power n dx. So what's the antiderivative? We add 1 to the x and divide it by that. So I'll write that in a different color. So what we do is we add 1 and divide it by that, x n plus 1. So what we get here is n x to the derivative would be, so this would be the antiderivative. Antiderivative would be n plus 1 divided by n plus 1. So that's the antiderivative of n x to the power n. Now let's differentiate it. Differentiate. How do we differentiate it? When there is a x to the power n, we multiply it by the power and subtract 1. So when you multiply it by the power, n plus 1 x to the power n, and we also have to add this o under in the denominator, so n plus 1. So we do get x to the power n. Of course, and as we get the antiderivative, we need to have a c. But when you differentiate, the c becomes 0. So we get x to the power n. So here I've shown you how when you have a function, you get the derivative and the antiderivative of the derivative. You get the same function. Or you get the antiderivative and get the derivative of it. You get the same function. And you can do the same for all the functions in that table. So let's look at this table, and we will try to use this table to do some questions. For example, if fx is equal to x to the power 5. So we use this equation number 1 to get this. So we say integral fx is equal to, what you do is you add 1 to the 5 and divided it by that value. So you add that 6 over 6 plus c. Let me move this table down. So now we have moved the table. Let me do another question. That's question number 1. And the second question is gx. Let's say gx is equal to 1 over square root of x. We know 1 over square root of x can be written as x to the power minus half. Now how do we integrate gx with respect to x? Dx is equal to, this is x, is equal to, what we do is add 1. So if we add 1, we get plus, let me do that here. So if we add 1 here, we get positive half. So we have to divide it by that. So we do x to the power half, right? And we divide it by half plus c. So it is 2x to the power half plus c. That's a constant. When you integrate or when you get the antiderivative, you have to have a c there. So the next question we'll do is third question. Hx equals sine 2x. So integration or antiderivative of hx would be, we see that the derivative of sine x is minus cos 2x divided by 2 plus c. So we use this equation to answer that. Then let's see fourth one, another question. Let's look at if ix is equal to cos x over 2. Then antiderivative of ix is equal to sine. We know sine, it's x over 2 divided by half plus c. So it would be 2 sine x over 2 plus c. So if we can do one more question. Let's say the fifth question. If jx is equal to e to the power minus 3x. Now we are using this equation for that, e to the power minus 3x. So all we do here is we divide it by 1 over 3 e to the power minus 3x plus c. So I have used mostly equation num 1, 2, 3 and 8 to solve these questions. Let's do a few more questions. Let's see how we get the antiderivatives of these functions. So if we look at a equals 2x, so integration of 2x dx. Let me draw the integral sign better. So integral of 2x would be, so we add 1 to the power of x. So we have x squared over 2 and we have this 2 here plus c. So it is really, it's equal to x squared plus c. So let's look at 6x. I will do it here. Integral sign of 6x dx is equal to, so we add 1 to the power of x, so it's 6x to the power 2 divided by 2 plus c. So that is equal to 3x squared plus c. So we'll do the third one here. Integral minus 3x to the power 4 minus 4. We add 1 to the power and divide it by that. So if we add 1 to the power, it's minus 3. So let's do 3x to the power minus 3 divided by minus 3. And we can cross these off. I'll do that in a crossing off. I'll do it in a different color so that you won't get confused. So that we will have plus c. So the answer would be x to the power minus 3 plus c. So let me do this question next. Integral, antiderivative integral 2x to the power minus 3 dx. This needs a dx as well. So here we add 1 and divide it by the value. So it will be 2 divided by x, sorry, 2 divided by minus 2, x to the power minus 2 plus c. So we can cross these off as a different color and we'll go back to the original color. So we would get here minus x minus 2 plus c. Let's do this question next. So here, integral sine of 1 over x squared dx. So we can write this as x to the power minus 2 dx, integral sine of that. So what we do here is add 1 to the power and divide it by that. So you get minus x minus 1 plus c. And if we look at question 6 here, and look at question 6, so we see it is my integral sign minus 2 over x to the power 3 dx. What is the integral or the antiderivative of that? So we can write this as integral minus 2 times x to the power minus 3. So when you get the antiderivative of this, we add 1 to this, which becomes minus 2 and divide it by 2. So we get x squared, we get minus x minus 2 plus c. Because when you add 1 to this, you get minus 2 and we divide it by minus 2. Then these two get crossed off. So we get this value. I'll do one more on this slide and do the next others on the next slide. So if it's integration of 3 over 2 x to the power half. So what we do is add 1 to this and divide it by that value. When you add 1 to this, you get 3 over 2, and when you divide it, you get these get cancelled off. Let me write that step again. 3 over 2 and x to the power 3 over 2 divided by 3 over 2. So when these get crossed off, I'll use a different color to show that. These get crossed off. then the answer would be x to the power 3 over 2 plus c. Now I'll use another slide to do this, these questions. So let me do each of these. The antiderivative is always, oops, sorry, I should use a different pen. Antiderivative is always add 1 to the power of x. So antiderivative of x squared dx is equal to add 1 and divide by it. So it is x to the power 3 and divided by 3 plus c. And x to the power 7 would be integral x to the power 7 dx would be x to the power 8 over 8 plus c. And x to the power 4 integral x to the power minus 4 dx. If you get the antiderivative of this, when you add 1 to this, you would get x to the power minus 3 over minus 3 plus c. And if you get the antiderivative of this function, you will get the antiderivative of x to the power minus 3 over 2 plus x squared dx, and the antiderivative of that would be you first add 1 to this and divide it by that value, so it will be x to the power minus 2 divided by minus 4, because there is another 2, it's minus 4, plus x to the power 3 divided by 3 plus c. So let's look at this function. Here it can be written as 5, right, x to the power minus 2 dx. So the antiderivative of this is you add 1. So let me show this once more in a different color. You add 1 to this and you divide by that. That's how you get the antiderivative. So we have the antiderivative would be when you add, we don't need to write that, 5 minus 5 over x plus c. So the reason why you write that is because when you the value of this is minus 1, so it's minus 5 divided by minus 1 minus x. Let's do this. Antiderivative of 1 over 2x cubed dx. So we can write this as integral 1 over 2 x to the power minus 3. So when you add 1, you get x minus 2. So dx. So when you add 1, you get minus 2 and you divide it by minus 2. So you get minus 1 over 4 x to the power minus 2 plus c. So if you look at this, it can be written as integral 2 square root of x dx can be written as integral half x to the power minus half. So when you add 1 to this, you get when you add when you add 1 to it, you get half. So we have x to the power, and you divide it by half, so you get x to the power half plus c. Let's do more questions. Let me quickly do these questions. This is in Thomas's Calculus book. So if we bring a different color, so let me do 25 here. Integral x plus 1 dx is equal to when we integrate x to the power 1, we get x squared and we divide it by 2. So we take this, add 1 to the power and divide it by that, plus x, this is 1 means x to the power 0. So we get x here plus c. And if we look at this question, we have integral 3t squared plus t over 2 dt. We to integrate, we take the power, add 1 and divide by that. So we get t to the power 3 and we divide it by 3, so this gets cancelled off. And next one is t to the power 1. We add 1, so we get 2 to the power 2 divided by 2. We get 4 plus c. So let's look at this integral of 2x to the power 3 minus 5x plus 7 dx would be, so here we take this power and 1 and divide it by that value. So we have, when we add 1, we get 4. So we get x to the power 4. When you divide it by 4, we have a 2 remaining. And minus 5, add 1 to the power, we get x squared divided by 2 plus 7, and 1 to the power 7x plus c. The next question, this question, integral 1 over x squared minus x squared minus 1 over 3 dx. And what we do here is, this is x to the power minus 2, and when we add 1, we get x to the power minus 1, and we multiply it by that value as well. Then here it is x to the power 2 and 1, you get x to the power 3 divided by 3 minus, this is x to the power 0 here, it's x to the power 0, so it's 1 over 3x, because x to the power 0, it turns into x, and minus x plus c. And let me do this next. So we have integral x to the power minus 1 over 3 dx. And when you add 1 to this, you get, I'll do it in a different color. Here we say minus 1 over 3 plus 1 is equal to 2 over 3, because you just take 1 over 3 off of 1. So then, since we have 2 over 3, the answer would be x to the power 2 over 3 divided by 2 over 3 plus c. That is 3 over 2 x to the power 2 over 3 plus c. Okay, let me do a few more questions. So integration of this, let me write this again, integrate 5 minus 6x dx. So this is equal to, this does not have an x, so x to the power 0, and when you add and divide it by the power, you get 5x divided by 1 minus 6x, x to the power 2, so 6x squared divided by 2 plus c. So this is 3. And let me do this. I'll use a different color for that. Integral t squared over 2 plus 4t squared dt. And the integration of this is t becomes, you add 1 and divide it by that, so you get t 3 over 6 plus t 4, because, oh sorry, this should be t3, so t4 divided by 4 plus c. So here integral of 1 minus x squared, x squared minus 3x to the power 5 dx, that would be 1 is equivalent to, let me rewrite this, this is 1 x to the power 0. So we write this as x, because 1 x to the power 0 is, when you add 1 you get an x here, and then minus divided by, add 1 and divided by 3, x to the power 3 divided by 3 minus x to the power 6 divided by 2 plus c. So here you have to remember, you divide by, you add 1 and divide it by. So when you add 1 here, you get 6, and divided by 6, you cancel out, so you get 3 here. So let me do this as well. Integral 1 over 5 minus 2 over x to the power 3 plus 2x dx. So the integral of that is 1 over 5 would be x over 5 plus x to the power minus 2, because this is minus 3. When you add 1, it's minus 2, and when you divide it by 2, you get these cancelled out. The minus 2 gets cancelled out, so you get x squared plus c. And if you do this, it would be integral x to the power minus 5 over 4 dx. Let me do this step by step. So you add 1 to this. When you add 1 to this, all you get is 1 over 4 minus 1 over 4. You get minus 1 over 4, because this is 1 plus 1 over 4. So this would be minus 1 minus 1 over 4. When you add minus 1 and minus 1 over 4, you get minus 5 over 4. So this would be minus 4 x to the power minus 1 over 4 plus c. I hope you enjoyed this. I'll have more videos on integration in the future.